I think, the only thing different between yesterday's lesson and the day before was the complexity of the denominators. The day before we learned how to do ones like 1 or 2 or 3 or 4, where all of the denominators had factors. They were all linear factors, and none of those factors that were linear had a multiplicity. And yesterday we looked at situations like number 9 that you're looking at here, where you have linear factors. There are 3 linear factors, but one of them has a multiplicity of 2. And when you break apart number 9 into partial fractions, what you're going to do is you're going to say that that's equal to some, you need a little more room, I suppose. That's equal to some constant over x minus 4 plus some other constant over x minus 1 plus a third constant over x minus 1 squared. And then determining, based on that equivalence, the value of a, b, and c becomes an algebraic procedure. There's lots of things you can do. You can set up systems of equations. You can put in numbers. You can put in numbers for x that clear out certain terms. By the way, you would definitely have to take what I have written here and multiply both sides by all of those denominators. So that's what we did yesterday. We just extended it a bit beyond what we did on the first day. But we also looked at situations like number 12, where you would break this into a constant over the factor x minus 5 plus over x squared minus 2x plus 3, which is non-factorable. We learned that you need a linear numerator there. But again, it becomes an algebraic, puzzle's the wrong word, it becomes an algebraic exercise to use all of your math skills to determine a, b, and c. We also looked yesterday at how you can go with a matrix and go with reduced row echelon form, because some of you are going to take linear algebra next year, I would suspect, or it's in your future, potentially. All that being said, does anybody have any questions from the ones that I recommended, or any other questions, period? All right, so seeing none, we're going to move on now to the third part of partial fractions. This is the final lesson in the unit, the final lesson in the course. There are other methods of integration. We might explore them a little bit over the coming week when we talk about the future for many of you. How many of you for sure are taking calculus next year? Okay. So, we've looked at substitution as a method. We've looked at integration by parts and integration of, quote, partial fractions. There are other methods as well. There's trigonometric substitution. There's all kinds of things you can do. Today what we're going to do is look at more rational expressions as integrands. But the difference here today is the numerator degree is no longer less than the denominator degree. In the first example, they're the same degree in the numerator and denominator. And in the second example, it's going to be a higher degree in the numerator or denominator. And in either case, you have to do something first. It is absolutely a fatal mistake for you to start going, oh, okay, I'm going to try to take x plus 4 over x minus 2. Well, it doesn't even make sense, does it? It doesn't go anywhere because it's not even equal to a, it's equal to x plus 4. So this doesn't work. Even if I had multiple factors in the denominator, it's still not going to work. And it has to do with the fact that the degree on the top is not smaller than the degree on the bottom. So what we need to do is rewrite this in a different form using division. Now, I've chosen this example strategically to talk about things you learn in Math 30-1 and things you need to know in 30-1 if you're in there right now, which is that What we're really going to be doing with this example is rewriting it in this form for you Math 30 people. And we're going to do it using synthetic division, and then I'm going to show you how to do it using long division, because when we do what we're about to do here with this one, and we do it with this one, you can't do synthetic division here, because the denominator is not x minus a. So you need to know how to do long division. But we're going to start by doing synthetic division here. I want to remind you, though, before I begin, that if I ask you what is 21 divided by, I'm going to go 22 instead. What is 22 divided by 3? We know the answer is 7 with a remainder of 1. Can you just mentally digest that statement? Does that make sense to you? Okay. But of course, this is an elementary school or a childish almost way of writing 22 over 3. It's really that 22 over 3 is equal to 7 plus 1 over 3. And for those of you that have been away from Math 30 for a very long time, this is called the division rule or the division algorithm, where a dividend, I don't like to throw that word in here, where a thing over a divisor is equal to the quotient plus the remainder over the divisor. That thing has a word, it's called dividend, but it's unimportant, right? So when you do division, that's the rule that we use. To, how can I put this? That's the rule that we use to connect all of the players in the division. So what we are going to do is divide x plus 4, which using synthetic division gives us this setup, by x minus 2, and when we do synthetic division, we put the 0 of the divisor in that spot to the left of that kind of L-shaped box. And we bring down the first one. And then you multiply and add until you get to the end. Your very last entry in synthetic division will be the remainder. Everything else below the line is the quotient. So I multiply that 2 by the 1 and I get 2, and I add these and I get 6. So what does that mean? It means that this gives us a quotient of 1 with a remainder of 6. That's what that means divisionally speaking. When I divide x plus 4 by x minus 2, I get a quotient of 1 and a remainder of 6. But according to the division algorithm, what that means is that x plus 4 over x minus 2 is equal to 1 plus 6 over x minus 2. We can confirm this, by the way. We don't need to, but some of you, it's been a while since you've done any kind of division of polynomials. We can confirm this by saying I'm going to put both of these over x minus 2. That would mean that this term here has to be multiplied top and bottom by x minus 2. So we get x minus 2 on the top. And you put these together, and it's pretty easy to see that you're going to get x plus 4 on the top and x minus 2 on the bottom. So that box is checked. It's correct. So what does this mean? Well, we can finish the question, and then I'm going to show you the long division. It means that the integral of x plus 4 over x minus 2 dx is the same as the integral of 1 plus 6 over x minus 2 dx. So again, we're using the integration in all of this final topic, all 3 days of it, is just taking the integrand and breaking it apart in some way. We wouldn't call these partial fractions, but we've torn it apart using division. And that's pretty easy to do. You certainly don't need to do this. But I hope everybody sees how I can write the integral of 1 minus 6 over x minus 2 dx as the integral of dx plus 6 times the integral of 1 over x minus 2 dx. It's overkill, I get that. But I think I'm doing you a favor by doing this, writing that, because next year you'll see a lot of that for reasons that are necessary. So this becomes x plus 6 ln of x minus 2 plus our constant. So looking at this question in its entirety, all of this middle part here, everything in this region, is simply us getting to the point where we can rewrite the integral. Does anybody have any questions with that? Okay, now we need to learn long division. And I made a decision, I think in semester 1 when I taught Math 30-1, I showed the people long division because I said you might see it in calculus. But I made the decision this current semester of just not even doing it because it just eats up class time. It confuses the students who don't need to know long division. And I think if you're in this class by now, you'll be able to handle learning it for the first time if you've never seen it before. So instead of doing synthetic division, and you can find room on that page, I gave you lots of room on this page. Let's do long division now with this. We're going to put x plus 4 here and divide it by x plus 2. It's going to be a very simple long division. It's not going to take us long at all. When you do long division of polynomials, though, everybody, that was weird. When you do long division of polynomials, there's a division, multiplication, and subtraction phase, right? When you do the division, you only look at the highest degree terms. You ignore the numbers here and you say, how many, quote, times does x go into x? And so what you're really asking is this. What is this equal to? It's equal to 1. But 1 is a degree 0 term, so it has to be written in the degree 0 column. It's a little bit different than working with numbers. Because when you do it with numbers, you just start loading the numbers up top. Now I multiply 1 by this entire thing and get x plus 2, and I subtract. But you have to subtract the whole thing. And it's minus 2, isn't it? So you have to subtract the whole thing. You have x minus x, which is 0, and then we have 4 minus negative 2, which is 6. And we don't need to go much further with this example. You can see that we got a remainder of 6 and a quotient of 1. So that means this integral is equal to the integral of the quotient plus the remainder over the divisor. Are we okay with that? Okay, so that's how we would get to this if we didn't want to use synthetic division. Now let's take a look at the final one, the final example. Since the degree on the top is not smaller than the degree on the bottom, you have to use division to begin with. Since the denominator is not a linear factor of the form x minus a, you have to use long division. Synthetic division will not work here. Okay? So how do we do this? Well, we're going to divide x squared minus 4 into 2x cubed minus x squared minus 3x plus 2. And you're going to start dividing. Divide, multiply, subtract. Divide, multiply, subtract. There's a little bit of a difference here between working with numbers, and it's this. You know you're done when you can no longer divide. Okay? You can no longer divide if the thing you're trying to divide into won't allow x squared to fit. So if at some point we subtract and get x's, then we have to end there because x squared cannot divide into x. not without introducing negative exponents, which is what we don't want. So you start by saying, what is 2x cubed over x squared? And the answer is 2x. Well, we have to put it in the column with the x's. Just like if you get 200, you have to put that 2 that represents the hundreds in the column with the hundreds. And now we multiply. We ignored this negative 4 when we divided, but when we multiply, we include everything. So you go 2x times x squared is 2x cubed. And these have to be equal. Unlike with numbers, sometimes they're not. These have to be equal. And then 2x times negative 4 is negative 8x. And we have to write that in the column with the x's. And now we're going to subtract that from what's above it. And it's this gaping chasm in here that bothers some people. If it bothers you, put plus 0x squared in there if it makes you happier. We're just not subtracting anything from what's above in that column. So what do I get? I get 2x cubed minus 2x cubed, which is nothing. I don't need to write that. I get negative x squared minus nothing, which is negative x squared. And I have negative 3x minus negative 8x, which is plus 5x. And now I repeat the process. And it might be at this point that you'd go, well, I'm going to bring the 2 down. We can bring the 2 down now or later. It doesn't matter. We can bring the 2 down if we need the 2. That's my point. And we will. I'm just going to leave it there for the time being. So again, negative x squared minus 0x squared is still negative x squared. Negative 3x minus negative 8x is positive 5x. So how many times does x squared, quote, go into negative x squared? Well, negative 1. So we're going to have a negative 1 here, and then we multiply. Negative 1 times x squared is negative 1x squared. And again, these have to be equal. And negative 1 times negative 4 is plus 5, which has to be in this column. Sorry, plus 4, which has to be in that column. And you're going to subtract. But, I mean, how do you subtract? Well, this is 0. How do you subtract the 5x minus something? Well, the answer is you have no x. What do we take the 4 away from? That 2. So what is it that we get when we subtract? We get negative x squared minus negative x squared is nothing. 5x minus nothing is 5x. And 2 minus 4 is negative 2. So we are done with the division, not just because we've hit the end of the line here or the end of the line here, but this degree is now higher than the degree of what we're trying to divide into. So we're done. What does that mean? It means this is the remainder. This is the quotient. Of course, this is the divisor. And we know that the original integrand is equal to the quotient plus the remainder over the divisor. So let me write that out. I'm just putting it here so you can see it in its totality. X cubed, x squared, x. That this now becomes the integral, I better make sure I wrote that down correctly, 2, negative 1, negative 3, 2, that's good, is equal to the quotient, the integrand is equal to the quotient of 2x minus 1 plus the remainder over the divisor. You okay with that? We can certainly verify this. I don't think, well, you can if you want. If you wanted to, you could multiply top and bottom of 2x minus 1 over 1 by x squared minus 4, FOIL out the top and gather all of the terms. You're going to get the original numerator of the original integrand. So that means our answer will be the integral of 2x dx minus the integral of dx plus the integral of 5x minus 2 over x squared minus 4 dx. I'm treating that 2x minus 1 as 2x minus 1. Okay, I'm just breaking it up. The integral of 2x dx is easy. That's x squared. The integral of dx is easy. That's x. The question becomes, how do you integrate 5x minus 2 over x squared minus 4? Does anybody have any ideas? Jay? We can try substitution, okay? It's close because the top is degree 1. You're thinking that u will be this? Okay, let's try and see what happens. If u equals x squared minus 4, then du, that's a u, then du equals 2x dx. I don't think we can get a 2x dx there because this negative 2 is screwing things up, isn't it? If that negative 2 were not there, yes, it would work. We could extract that 5 and manipulate this to make it work. So unfortunately, substitution in this case doesn't work. Sometimes it will at this point, but in this case it doesn't. You got another idea?
Split up the denominator and do parts.
Partial fractions now. Right, because now that radicand, not radicand, that integrand has a lower degree on the top than the bottom, so it qualifies for partial fractions. We need to take 5x minus 2, so it's a major detour, 5x minus 2 over x plus 2, x minus 2, and tear it apart into a over x plus 2 plus b over x minus 2. If that x squared minus 4 were non-factorable, there's nothing you can do. I'm not saying there's nothing that can be done. There's nothing that you can do. At this point in time, a single non-factorable quadratic is a dead end for you unless substitution happens to work. And sometimes it does. Okay? If at this point in time you get the following, then substitution will work. Because if the bottom is u, then 6x dx is du, and you can make that work with substitution. Okay? So I'm going to just shave off a little bit of time here. I think we all know that both sides of this equation need to be multiplied by x plus 2, x minus 2, yeah? To clear the denominator, so you get 5x minus 2 equals a times x minus 2 plus b times x plus 2. Let's do it with a system of equations, because there's only a and b, so it's not a complicated system of equations. Are we okay with that step, you guys? Any questions there? Okay. So if I expand this out, I get ax minus 2a plus bx plus 2b. That means that a plus b has to equal 5. it means that negative 2a plus 2b has to equal negative 2. So ax plus bx is 5x, a plus b is 5. Negative 2 is equal to negative 2a plus 2b. Just because, let's create a matrix. This will be a 2 by 3 matrix. We want this first number in the top left to always be a 1, and it is. We want the number below it to be a 0. So I can make the number below it 0, and by the way, you could probably get the answer quicker just by rearranging the equations. But I can get this bottom number to be 0 by taking 2 of the top and adding it to the bottom, and if I do that, I get 0. 2 times 1 is 2, plus 2 is 4. 2 times 5 is 10, plus negative 2 is 8. I can divide everything in this row by 2. Whoops, I want to double check that. 10 minus 2 is 8, 2 plus 2 is 4, 2 minus 2 is 0. So I get 1, 1, 5, 0, 1, 2. We've already discovered that b is 2 because this bottom row is saying 0a plus 1b equals 2. If I want to know what a is, I need to make this a 0. So I can take the top equation and subtract the bottom equation and write the result in the top. 1 minus 0 is 1, 1 minus 1 is 0, 5 minus 2 is 3. So a is 3, b is 2. I think that's overkill. Okay. If you take a look at this, if you were to double this top equation and add them, you would get 4b equals 8. You'd get b equals 2. It's a lot quicker, but I wanted to show you the matrix thing again. So, bottom line now, a is 3, b is 2. That means our answer is, are you okay with me erasing this right here? Okay. I just want to get some continuity up here. You can look at your whole sheet and see everything on it. So our answer is x squared minus x plus the integral of a, which was 3. Did I have my a over x plus 2? Okay, plus 2, plus b, which was 2 over x minus 2 dx. And we can finish the problem off now. X squared minus x plus 3 ln of x plus 2 plus 2 ln of x minus 2. Boy, that natural logarithm thing plus c makes things easy. That's it. That's the answer. So now if you take a look at the bottom of this page and it tells you what the practice is, this is all about problem set C, and problem set C is all of the ones where the numerator degree is either the same degree or higher than the denominator. So you have to do synthetic division first. Oh, sorry, long division first. I don't know that you're going to be able to do synthetic division for many, if any of those. Okay. Okay, let's have our discussion about the exam. What say you? No exam? Okay, I think I'm going to go with that. It'll make my life a little easier too. I am going to give you probably Thursday. I'll see if I can find time. I'll put together a short assignment that's an integration assignment. There'll probably be a couple of questions dealing with area and a couple of questions dealing with integrals. And it will be due maybe Tuesday or Wednesday of next week. Earlier, if you want it marked before you write your field test on Thursday. I'm also going to, I tried sending it to the photocopier, but there was an issue. I'm going to photocopy some review materials for this unit. So today what you're going to be working on are problem set C and the review materials for this unit that I will get to you today. I guess I will have to try to get that assignment to you for tomorrow. So I'm going to give you the assignment probably tomorrow. I'm also going to give you all kinds of year review materials tomorrow. Practice final exams, that kind of stuff. Okay, so get to work on that, please.